All right, so let's go ahead and go back through our classification. Okay. All right, so we have an equilateral triangle. Okay. What kind of triangle is this right here? Kind of, but these little curves right here means that all three angles are equal to each other. So from the selections that I have left, what triangle would that be? Equiangular. Very good. Okay, we'll try this one then. Okay. All right, Maddie, what kind of triangle is this? There's a little box in the corner right here. A right triangle. All right. Somebody else. What is this triangle? Two sides are equal to each other. Isosceles. What kind of triangle is this right here? Obtuse. Because this is an obtuse angle right here. Huh? I guess it could be. I probably would have gone with, because if I'm looking at the three choices here, down to one of the other two choices are going to be obtuse most likely. So I would have put obtuse here. And then if I'm looking at an acute triangle, really either one of those could be it, and then we could take a cascading triangle. Okay, but we've got the point. All right. So what do the sum of all the measures of a triangle equal up to when you add them together? 180 degrees. So this is 180 degrees. Nope. So 180. Good. So if this angle right here is 88 and this angle right here is 42, what's the measure of this? Just got quick with it. 50. Okay. All right, so 50 it is. So therefore, there's a corollary. Okay, corollary means it's basically a supplement to what it is that we just talked about. All right. So if I have a right triangle here, the other two angles are going to be acute. All right. What does it mean if this angle is 90? What do these two angles added up together have to be? And when you have two angles that add up together to equal 90, what do we call those angles? No, the other one. Complementary. Okay. Let me go back and change this slide. I did this slide a couple years ago and I didn't know how to spell that. Thank you for pointing that out. All right, so here's what I want you to do. All right. First, solve the variable, then name the triangle by the angle. Okay? So you have a triangle WYX, and I want you, or WYZ, sorry, WYZ, okay? Find the value of X and tell me what kind of triangle it is. Essence, if this triangle right here is 90, what do these angles right here have to add up to equal? So therefore, x minus 15 plus 2x minus 165 has to equal 90 degrees. All right, so what does x equal here? All right, and this is a right triangle because we have one angle which is 90 degrees. Good. All right, so this is going to be important. I want everybody to pay attention. So if I have a triangle right here, triangle ABC, okay, we can clearly find out what the third angle is here, okay? But when you have a triangle, at some point, you're going to have an exterior angle, okay? An exterior angle. So when you're looking to find the exterior angle, this is the reason why it's called the exterior angle theorem. The exterior angle theorem. All right, so exterior angle means that in order to find this exterior angle, I'm going to add up the two angles that are not next to it. That's what that means, two non-adjacent interior angles. What that means is, to find this angle, add up the two angles that are not next to it. So I'm going to add this and this to get angle 1. All right? So angle 1 is going to be 136. So the theorem says to find the exterior angle, to find angle 1, we would add up angle A plus angle B. Does that make sense? Yeah. Okay. Now, it certainly gets a lot more complicated than this. But again, it's just like anything else. If you know the basics, then you can apply the more complex ideas to it. All right? Find all 9 angles. Okay? So this is going to be 75. Okay? Now the other way to do that would have been to say, well, this is a linear pair. Okay? So 125 minus 180 would have given you this angle. What is this angle right here going to be? 55. Okay? So again, you could have gone that route and added these two together and subtracted from 180. But what's the relationship between angle 2 and angle 3? But what do we call them? Vertical. Okay, so they're vertical angles, so 2 is congruent to 3, so 3 is 55 degrees. All right, so what does that make angle 4? 40. Okay, because if I add up 55 and 85, we get 140. 140 or 180 minus 140 is 40. All right, so 4 and 5 are a linear pair. What is angle 5? 140. 4 and 6 are vertical. What's 6? 40. We come over here, 65 and 8 are vertical. What's 8? 65. We add these two together and subtract from 180. What do we get for 7? 75. And 8 and 9 are a linear pair, so 9 is what? Huh? 115. And we can see that checks because if angle 9 is an exterior angle and it's 115, then these two angles that are not next to it should add up to it. Indeed, 75 plus 40 does equal 115. All right, good job. So, all right, that was good. Okay. So here's what you're going to